Hi, my name is Petri Kainulainen and this is the third part of my tutorial which talks about the unit testing of Spring MVC controllers. This video describes how we can write unit tests for a REST API by using the Spring MVC Test Framework. By the way, if you have not watched the first and second part of this video tutorial, I recommend that you watch them before watching this video. Okay, let's get started. This tutorial is divided into three parts. The first part describes how we can get the required testing dependencies with Maven. In the second part, we will take a quick look at the core components of the Spring MVC Test Framework. We will also learn what role these components play in a typical unit test. The third part describes how we can write unit tests for a REST API. The first thing that we have to do is to get the required testing dependencies. Let's see how we can do this. We can get the required testing dependencies by adding the following dependency declarations to our POM file. Hamcrest all version 1.3. We use Hamcrest matches when we are writing assertions for the responses. JUnit version 4.11. We need to exclude the Hamcrest core dependency because we already added the Hamcrest all dependency. Mockito core version 1.9.5. We use Mockito as our mocking library. Spring test version 3.2.3. Release. JSON path version 0.8.1 and JSON path assert version 0.8.1. We use JSON path when we are writing assertions for JSON documents returned by our REST API. Let's take a quick look at the core components of the Spring MVC Test Framework and see what role these components play in our unit tests. Every unit test which tests the behavior of a controller method consists of two steps. 1. We send a request which is processed by the tested controller method. 2. We verify that we received the expected response. The Spring MVC Test Framework has a few core classes which we can use for implementing these steps in our tests. These classes are described in the following. We can build our requests by using the static methods of the mock MVC request builders class. These methods return request builder objects which are passed as a method parameter to the method which executes the actual request. The mock MVC class is the main entry point of our tests. We can execute requests by calling the perform method. This method takes a request builder object as a method parameter. We can write assertions against the received responses by using the static methods of the mock MVC result matches class. Because we'll write unit tests for a REST API, we have to be able to write assertions for the JSON document returned by our API. We can use the JSON path method of the mock MVC result matches class for this purpose. This method takes two parameters. The first parameter is the JSON path expression which is used to fetch data from the JSON document. The second parameter is a Hamcrest matcher which is used to make assertions for the fetched data. Next, we will write some unit tests for our example application and see the core components of the Spring MVC Test Framework in action. During this video, we will write unit tests for 3 controller methods. I selected these methods because I think that A. Writing tests for these methods gives us a relatively good idea about the usage of the Spring MVC Test Framework. B. The other controller methods are pretty similar than the tested methods. In other words, writing tests for these methods would not add any value to this video. The tested controller methods are: the first controller method returns a list of to-do entries. The second controller method returns the information of a single to-do entry. The third controller method is used to add new to-do entries to the database. First, we will write unit test for a controller method which returns a list of to-do entries. Let's start by taking a look at the implementation of this controller method. The controller method, which returns all to-do entries stored to the database, is implemented by following these steps. 1. It processes GET requests sent to URL/API/todo. 2. It gets a list of to-do objects by calling the findAll method of the to-do service interface. This method returns all to-do entries which are stored to the database. These to-do entries are always returned in the same order. 3. It transforms the received list into a list of to-do DDO objects. 4. It returns the list which contains to-do DDO objects. When a list of to-do DDO objects is returned, Spring MVC transforms this list into a JSON document which contains a collection of objects. The returned JSON document looks as follows. Let's move on and find out how we can write a unit test which ensures that this controller method is working as expected. We can write a unit test for this controller method by following these steps. 1. Create the test data which is returned when the findAll method of the to-do service interface is called. We create the test data by using a test data builder class. 2. Configure our mock object to return the created test data when its findAll method is called. 3. Execute a GET request to URL/API/todo. 4. Verify that the HTTP status code 200 is returned. 5. Verify that the content type of the response is application JSON and its character set is UTF-8. 6. Get the collection of to-do entries by using the JSON path expression $, and ensure that 2 to-do entries are returned. 7. Get the ID, description and title of the first to-do entry by using JSON path expressions and verify that the correct values are returned. 8. Get the ID, description and title of the second to-do entry by using JSON path expressions and verify that the correct values are returned. 9. Verify that the findAll method of the to-do service interface is called only once. 10. Ensure that no other methods of our mock object are called during the test. Our unit test uses a constant called application underscore JSON underscore UTF-8, which is declared in the test_util class. Let's take a quick look at the test_util class. The value of the application underscore JSON underscore UTF-8 constant is a media type object which content type is application JSON and character set is UTF-8. Second, we will write unit tests for a controller method which returns the information of a single to-do entry. Let's move on and find out how this controller method is implemented. The controller method which returns the information of a single to-do entry is implemented by following these steps. 1. It processes GET requests sent to URL /API/todo/ID. The ID inside the curly brackets is a path variable which contains the ID of the requested to-do entry. 2. It obtains the requested to-do entry by calling the findById method of the to-do service interface and passes the ID of the requested to-do entry as a method parameter. This method returns the found to-do entry. If no to-do entry is found, this method throws a to-do not found exception. 3. It transforms the to-do object into a to-do DDO object. 4. It returns the created to-do DDO object. The JSON document which is returned to the client looks as follows. Our next question is, what happens when a to-do not found exception is thrown? Our example application has an exception handler class which handles application-specific exceptions thrown by our controller classes. This class has an exception handler method which is called when a to-do not found exception is thrown. The implementation of this method writes a new log message to the log file and ensures that the HTTP status code 404 is sent back to the client. Now we have to write two unit tests for this controller method. 1. We have to write a test which ensures that our application is working properly when the to-do entry is not found. 2. We have to write a test which verifies that the correct data is returned to the client when the to-do entry is found. Let's see how we can write these tests. First, we must ensure that our application is working properly when a to-do entry is not found. We can write a unit test which ensures this by following these steps. 1. Configure our mock object to throw a to-do not found exception when its findById method is called and the ID of the requested to-do entry is 1. 2. Execute a GET request to URL /API/todo/1. 3. Verify that the HTTP status code 404 is returned. 4. Ensure that the findById method of the to-do service interface is called only once by using the correct method parameter. 5. Verify that no other methods of the to-do service interface are called during this test. Second, we must write a unit test which ensures that the correct data is returned when the requested to-do entry is found. We can write a test which ensures this by following these steps. 1. Create the to-do object which is returned when our service method is called. We create this object by using our testDataBuilder class. 2. Configure our mock object to return the created to-do object when its findBy method is called by using a method parameter 1. 3. Execute a GET request to URL /API/todo/1. 4. Verify that the HTTP status code 200 is returned. 5. Verify that the content type of the response is application/JSON and its character set is UTF-8. 6. Get the ID of the to-do entry by using the JSON path expression $.id and verify that the ID is 1. 7. Get the description of the to-do entry by using the JSON path expression $.description and verify that the description is lorem ipsum. 8. Get the title of the to-do entry by using the JSON path expression $.title and verify that the title is foo. 9. Ensure that the findById method of the to-do service interface is called only once by using the correct method parameter. 10. Verify that the other methods of our mock object are not called during the test. Third, we have to write unit tests for controller method which is used to add new to-do entries to the database. Let's check out how this controller method is implemented. The controller method which adds new to-do entries to the database is implemented by following these steps. 1. It processes post requests sent to URL /API/todo. 2. It validates the to-do DDO object given as a method parameter. If the validation fails, a method argument not valid exception is thrown. 3. It adds a new to-do entry to the database by calling the add method of the to-do service interface and passes the to-do DDO object as a method parameter. This method adds a new to-do entry to the database and returns the added to-do entry. 4. It transforms the created to-do object into a to-do DDO object. 5. It returns the created to-do DDO object. Next, we will take a quick look at the source code of the to-do DDO class. The to-do DDO class is a simple DDO class which declares three validation constraints. These constraints are described in the following. 1. The maximum length of the description is 500 characters. 2. The title of a to-do entry cannot be empty. 3. The maximum length of the title is 100 characters. Okay, let's go back to the to-do controller class and take a quick look at the returned JSON document. If the validation does not fail, our controller method returns the following JSON document to the client. If the validation fails, a method argument not valid exception is thrown. This exception is processed by our error handler class. Let's see what happens when this exception is thrown. When a method argument not valid exception is thrown, the process validation error method of the REST error handler class is called. The implementation details of this method are not described in this video. However, the description of this video has a link to my blog post which describes how we can add validation to a REST API. This method has two tasks. 1. It ensures that the HTTP status code 400 is returned to the client. 2. It processes validation errors and creates a new validation error DDO object which is returned after all validation errors are processed. This DDO is transformed into a JSON document by Spring MVC. However, we need to know what kind of a JSON document is returned to the client if the validation fails. If the title and the description of the to-do entry are too long, the following JSON document is returned to the client. Also, we have to understand that Spring MVC does not guarantee the ordering of the field errors. In other words, the field errors are returned in a random order. We have to take this into account when we are writing unit tests for this controller method. It's clear that we have to write two unit tests for this method. 1. We have to write a test which ensures that our application is working properly when the validation fails. 2. We have to write a test which ensures that our application is working properly when a new to-do entry is added to the database. Let's find out how we can write these tests. Our first test ensures that our application is working properly when the validation of the added to-do entry fails. We can write this test by following these steps. 1. Create a title which has 101 characters. 2. Create a description which has 501 characters. 3. Create a new to-do DDO object by using our test data builder. Set the title and the description of the object. 4. Execute a post request to URL /API/todo. Set the content type of the request to application/JSON. Set the character set of the request to UTF-8. Transform the created to-do object into JSON bytes and send it in the body of the request. 5. Verify that the HTTP status code 400 is returned. 6. Verify that the content type of the response is application/JSON and its character set is UTF-8. 7. Fetch the field errors by using the JSON path expression $.fieldErrors and ensure that 2 field errors are returned. 8. Fetch all available paths by using the JSON path expression $fieldErrors star inside square brackets .path and ensure that field errors about the title and description fields are found. 9. Fetch all available error messages by using the JSON path expression $.fieldErrors star inside square brackets .message and ensure that error messages about the title and description fields are found. 10. Verify that the methods of our mock object are not called during our test. Our unit test uses 2 static methods of the test_util class. These methods are described in the following. The convert object to JSON bytes method converts the object given as a method parameter into a JSON document and returns the content of that document as a byte array. The createStringWithLength method creates a new string object with the given length and returns the created object. The second unit test ensures that our controller is working properly when a new to-do entry is added to the database. We can write this test by following these steps. 1. Create a new to-do object by using our testDataBuilder class. Set legal values to the title and description fields. 2. Create a to-do object which is returned when the add method of the to-do service interface is called. 3. Configure our mock object to return the created to-do object when its add method is called and a to-do object is given as a parameter. 4. Execute a post request to URL/API/todo. Set the content type of the request to application/JSON. Set the character set of the request to UTF-8. Transform the created to-do object into JSON bytes and send it in the body of the request. 5. Verify that the HTTP status code 200 is returned. 6. Verify that the content type of the response is application/JSON and its character set is UTF-8. 7. Get the ID of the returned to-do entry by using the JSON path expression $.id and verify that the ID is 1. 8. Get the description of the returned to-do entry by using the JSON path expression $.description and verify that the description is description. 9. Get the title of the returned to-do entry by using the JSON path expression $.title and ensure that the title is title. 10. Create an argument capture object which can capture to-do DDO objects. 11. Verify that the add method of the to-do service interface is called only once and capture the object given as a parameter. 12. Verify that the other methods of our mock object are not called during our test. 13. Verify that the ID of the captured to-do DDO object is null. 14. Verify that the description of the captured to-do DDO object is description. 15. Verify that the title of the captured to-do DDO object is title. Let's spend a moment to summarize what we learned from this video. First, we learned to write unit tests for controller methods which read information from the database. Second, we learned to write unit tests for controller methods which add information to the database. Third, we learned how we can transform DDO objects into JSON bytes and send the result of the transformation in the body of the request. Fourth, we learned how we can write assertions for JSON documents by using JSON path expressions. That's all for today. You can get the example application of this tutorial from my website www.petrikainulainen.net. I have also added link to the description of this video. If you enjoyed watching this video, you might want to follow me at Twitter. My Twitter handle is @petrikainulainen. Thanks for watching. Hei hei!